Welcome to Learn with us. This is the third lecture of Basic Electronics.
First, we will have a quick review of previous lecture. In your last lecture, you studied about intrinsic and extrinsic semiconductors. You also understood currents in intrinsic semiconductors. In your previous lecture, you also studied about the difference between N-type and P-type semiconductors, and you also understood what is p-n junction. In your previous lecture, you also understood energy diagram of p-n junction and depletion region. What are the learning objectives of this lecture? In this lecture, you will study about electrical networks and components of electrical circuits. In this lecture, you will also understand what is Ohm's Law, what is voltage divider rule, and what is Kirchhoff's current law. Now, what are electrical networks? An electrical network is an interconnection of electrical components such as batteries, resistors, inductors, capacitors, switches, transistors, or it is a model of such an interconnection consisting of electrical elements, for example, voltage sources, current sources, resistances, inductances, etc. Electrical circuits include branch. Now, what is a branch? It is the portion of circuit consisting of one or more elements or a single path composed of one single element is known as branch. What is a node? It is a point where all the branches meet in the circuit. Now, what are sources? Sources are those elements which generate infinite amount of current and voltage. They are of two types. First is independent source. Independent sources are those which do not depend on any other quantity in the circuit. They are two-terminal devices having a constant value. Second type of source is dependent source. A dependent source is a voltage source or a current source whose value depends on a voltage or current elsewhere in the network. The circuit symbol for an ideal independent and dependent current and voltage sources are shown in this figure. As you can see, dependent voltage and current sources are represented by a diamond-shaped symbol, whereas independent current and voltage sources are round. These positive and negative signs on the voltage source symbol tell us the polarity. The direction of current flow in the current source is provided on the source symbol, as you can see here. It means there is no need to assume a current direction. Now, what are elements? The electrical component or part in the branch is called element of the circuit. There are two types of elements. First type is active elements. Active elements are those elements which do not have tendency to hold the charges. All the independent sources are active elements as they provide infinite amount of current to the circuit. For example, voltage source and current source. Second type is passive elements. Passive elements have the tendency to hold charges. All the dependent sources are passive elements as they provide finite amount of current to the circuit. For example, capacitor, inductor, resistor, etc. Now, what is a circuit? Combination of number of elements at the terminal points providing at least one closed path is called a circuit. There are two types of circuits. First type is series circuit. It is a circuit configuration in which elements have only one point in common and each terminal is not connected to the third current carrying element. In series circuit, current remains same. Second type of circuit is parallel circuit. It is a circuit configuration in which elements do not have one but at least 2 points in common. In parallel circuits, voltage remains same. Now, look at this circuit. This is a series circuit. As you can see, there are 4 elements in this series circuit. This resistor 1 is element number 1. This resistor 2 is element number 2. This resistor 3 is element number 3 and this battery is element number 4. Now when we talk about branches, there are 4 branches in this series circuit. This is branch number 1. This is branch number 2. This is branch number 3 and this is branch number 4. It means each branch is carrying one element. Now, how many nodes are there? There are 4 nodes. This is first node. This is second node. This is third node and this is fourth node. Now, look at this circuit. This is a parallel circuit. As you can see, there are 3 elements in this parallel circuit. This is element number 1, this is element number 2 and this is element number 3. Now, how many branches are there? There are 3 branches. This is branch number 1, this is branch number 2 and this is branch number 3. Now, when we talk about nodes, there are 2 nodes in this parallel circuit. This is first node and this is second node. Now, note that in both series and parallel circuits, number of elements are equal to number of branches. But when we talk about nodes, in series circuits, nodes are equal also, that is 4 in this case, but in case of parallel circuits, nodes are not equal to number of elements and number of branches. So, this is the difference between series and parallel circuits. Now, what is Ohm's law? Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. It is given by the equation V is equals to IR, where V is the voltage, I is the current, and R is the resistance. This equation determines voltage drop across a resistor. Now, look at this equation. This equation determines the current through a resistor. Now, this equation 1, it can be rewritten as R is equals to V upon I. This equation determines the resistance of an unknown resistor. Now, here is your class task. There are two circuits. One is series circuit and second is parallel circuit. If R1 is 2 ohms, R2 is 1 ohm and R3 is 5 ohms and V is 20 volts, then find current and voltage across each resistor in series circuit and find current across each resistor in parallel circuit. Take 5 minutes to complete this task. Now, what is a voltage divider rule? It is a modified form of Ohm's law. This voltage divider rule is the method to find unknown voltage of any element connected in series. This voltage divider rule is used when there is no clue of current. Now, look at this configuration. We know that from Ohm's law, I is equals to V divided by R. This is your equation number 1. Since all these resistors are connected in series, therefore R equivalent will be R1 plus R2 plus R3. Now, by putting this value of R equivalent in this equation 1, we get I is equals to V divided by R1 plus R2 plus R3. This is your equation number A. Now, if we want to find voltage across this resistor R2, that is V2, then for V2, the equation of Ohm's law becomes V2 is equals to I R2. By rearranging, we get I is equals to V2 divided by R2. Now, by putting this value of I in this equation A, we get V2 divided by R2 is equals to V divided by R1 plus R2 plus R3. By rearranging, we get V2 is equals to V multiplied by R2 divided by R1 plus R2 plus R3. Similarly, for V3, the above equation would become V multiplied by R3 divided by R1 plus R2 plus R3. So, the generalized equation will be Vx is equals to V multiplied by Rx divided by R equivalent. So this is the equation which is used for finding unknown voltage of any element connected in series. Now here is one example problem. If you have a circuit like this is R1 and this is R2. This R1 is 4 ohms, this R2 is 2 ohms. This is input voltage of 24 volts. This is ground. This is V1. This is V2 and this is the direction of current. Now you have to find V1, V2 and I using voltage divider rule. We know that Vx is equals to V multiplied by Rx divided by R equivalent. For V1, the above equation will become V multiplied by 4 divided by 4 plus 2. Here V is 24 volts. After solving, we get V1 is equals to 16 volts. Similarly, for V2, this formula will become V multiplied by 2 divided by 4 plus 2. Again, V is 24 volts. After solving, we get V2 is equals to 8 volts. Now, from Ohm's law, we know that V is equals to IR. Now, we have to find I. So, I is equals to V divided by R. Since these two resistors are connected in series, therefore R equivalent is R1 plus R2. Now I will become V divided by R1 plus R2. Here we know that V is 24, R1 is 4 and R2 is 2. After solving, we get I is equals to 4 amperes. So these are your unknown values. Now look at this circuit. If R1 is 2 ohms, R2 is 4 ohms, Vin is 10 volts, then what is Vout? From voltage divider rule, we know that Vx is equals to V multiplied by Rx divided by R equivalent. Here Vx is Vout, V is Vin. So how we are going to find this Rx? We know that this terminal of Vin is positive and this terminal is negative. So this terminal of R1 will be positive because it is connected to the positive terminal of Vin, and this terminal of R1 will be negative. Similarly, this terminal of R2 is connected to the negative terminal of Vin. So this terminal will be negative and this terminal will be positive. Now, we are going to select this R2 for our formula because this unknown voltage is connected to the positive terminal of this R2. Now, by putting all these values in this equation, we get Vout is equals to 10 multiplied by 4 divided by 2 plus 4 because both of these resistors are connected in series. After solving, we get 6.66 volts, which is the unknown voltage. What is Kirchhoff's current law? Kirchhoff's current law states that the algebraic sum of all the currents entering a node equals the sum of all the currents leaving that node. Now, look at this circuit. We can redraw this circuit like this. This is the branch containing R2. This is the branch containing R1, and this is the branch containing R3. So this is node A and this is node B. Now, when we look at node A, here one current is entering and three currents are leaving. So we can write here at node A, I is equals to I1 plus I2 plus I3. Now look at node B. Here three currents are coming and one current is leaving. So we can write it like this at node B, I1 plus I2 plus I3 is equals to I. So this is your Kirchhoff's current law. Now, if you have a circuit like this, okay, there is only one node A. Now, this is IA, this is IB, this is IC, and this is ID. So, how you are going to analyze this circuit? Now, first you will look at node A, then you will see how many currents are entering this node A and how many currents are leaving from this node. Now, as you can see, three currents are coming, that is current IA plus current IB plus current ID. They are coming towards node A, whereas current IC is going away from node A. So this is Kirchhoff's current law. Now, here is one example problem. If there is a circuit like this is R1, I1 is flowing through R1 in this direction. This is one current source of 2 amperes. This is R2 and I2 is flowing through R2 in this direction. This is R3 and I3 is flowing in this direction, and here is another current source I4. Now, if I1 is 6 amperes, I3 is 9 amperes, and I2 is unknown, and I4 is also unknown. So how you are going to solve this circuit? Now look at this circuit. This is node A and this is node B. Now first we look at node A. So at node A, how many currents are coming at node A? Only one current is coming, which is I1, and two currents are leaving. One is I2 and another is this source of 2 amperes. We know that I1 is 6 amperes. So after solving this equation, we get I2 is equals to 4 amperes. Now we will look at node B. At node B, how many currents are coming at node B? Two currents are coming. One is I2 and other is I4, and one current is leaving, which is I3. Now we just calculated that I2 is 4 ampere and I4 is unknown and I3 is 9 amperes. So after solving we get I4 equals to 5 ampere. So these are your unknown currents. So that's all for today. What are the key takeaways of this lecture? In this lecture, you studied about components of electrical circuits such as branch, elements, nodes, sources, etc. In this lecture, you also understood Ohm's law, voltage divider rule, and Kirchhoff's current law with the help of some examples.
Thank you for watching this video. If you have any questions, then write your questions in comment section of this video. Don't forget to subscribe our channel and share it with your friends and family. Thank you.